Okay, the last thing we'll look at is finding values of a random variable given the probability or area. Okay, so what we're going to do is in the table we're going to find the closest area and find its corresponding z-score. And just as before, we can find the z-scores on the calculator using inverse norm, area, mean, standard deviation. Okay, so this will be a little more complicated than the other types of questions. Okay, so graph each of the following and find the z-score with 0.7357 area to its left. Okay, so if we look at a graph of what that would represent, okay, we know that a z-score of 0 has 0.5 to its left. Okay, so if we go from here to the center, that's 0.5. Well, we want 0.7357, so we want to go a little farther than that. Now, we don't know exactly where it is yet, okay, but I'll just say it's to that line. Okay, so what we do is if we have 0.7357 area to its left, we can go to our z-table and find 0.7357. Now, what we don't look for is 0.7357 as a z-score because we're trying to find what z is. Okay, so we're not going to try to say 0.73 and do anything with that because we're given the area, which means we're given the body or the decimal in the body of the table, not the z-score. So 0.7357, we try to find it in here. Okay, and remember, when you're looking at this, remember that 0.5 means that you have 50% to its left. Now notice as you increase, as you go across the table, okay, and then across the rows, okay, what happens is they get larger. Okay, so we have 0.5 in the top row, and then as we work our way down, okay, notice we get larger and larger and larger until we eventually get to 0.9999, okay, which is basically 1, okay, if you keep on going. All right, so 0.7357. Can we find that in the table? Well, 7357, oh, there we go right here, which is a z-score of 0.63. Okay, so z equals 0.63. Okay, so this value is 0.63. So z 0.63. Okay, that's all you have to do. As far as our calculator goes, we would do inverse norm, area 0.7357, comma mean, comma standard deviation. Well, because we're on the standard normal curve, the mean was 0, and the standard deviation in the standard normal was 1. So 0, comma 1. Okay, so I'll just show you on the calculator here quick. Okay, so we do second vars. Okay, the distribution inverse norm is the third one down. And then 0.7357. Now I can just press enter because your calculator will assume it's a standard normal, but I'm going to say mean, comma, standard deviation of 1. Okay, 0.6301. Now remember, this is a z-score, so we're going to round those to the nearest hundredth. Okay, so approximately 0.6301, we're going to say z is approximately 0.63. Okay, so that's the z-score we're looking for. Okay, then we look at 0.0823 area to its left. Okay, so I'll let you look that up. Okay, and I'll put the answers up here again just for the sake of time. You find 0.0823. Okay, and that shows up as a z-score of negative 1.39. Okay, and then part C, 99% of the area to its left. Okay, so the diagram, you have 99% to its left, so that's an area 0.9900. Okay, you don't say 99 because 99% is 0.9900. Now you can see the answer to the z-score is 2.33. Okay, so when you look up 0.9900, okay, on that one, 0.9900, okay, well, as you go through this, notice there's a lot of 0.9s in here. Okay, so it takes a little getting used to. But 0.9900, well, there's 9904, 9901, 9898. So we notice that 0.9900 doesn't exactly show up. So what we do is we take the closest value. Well, when you look at 9900, that is 0.0002 above this one, and 0.0001 below this one. So it's closer to 0.9901. So that'll be a z-score of 2.33. Okay, so you take the closer value. Okay, now basically if you ignore the decimal places, just say is 9900 without not even looking at decimals. That's only 1 away from 9901 and 2 away from 9898. Okay, the decimal you don't really need to worry about in the context of trying to figure out which it's closer to. Okay, so 2.33 is the z-score that has 99% to its left. Okay, and again, if you did the calculator, inverse norm, it'll give you the same answer. Okay, then we look at area to the right. Well, 0.1350, area to its right, okay, when you look at that, oops, I'm going to do this. Okay, notice I have 0.8650 to the left. Well, this has to do with the complement idea, because when you look up the values in the table, that gives you the area to the left. Well, when we're looking at 0.1350 to its right, we're looking at the shaded area over here. And then the remaining area, or the complement of that, is 0.8650. So if you look up 0.8650, okay, what we see is 1.10 will be closest to that. Okay, so 0.8650, 8650, well, let's see, there's 85, 85, 85, oh, 0.8599, and we're looking for 8650. Okay, so that's between 8643. So you can think about that as being 7 above 8643, and then 8665 is 15 above that. So what's it closest to? 8643. So the z-score, 1.10. Okay, so that's where the 1.10 is coming to. It's closest to that one. Now, one thing I will point out is that if you actually look up 0.1350, if you look up that area, because of the symmetry, that will be the same area as will be to the left right here. So that means whatever z-score this is right here is going to be symmetric to this z-score. So if you look up 0.1350, well, 0.1350, well, there's 1357, and there's 1335. So it means we're 15 above this one and 7 below this one. So we're closest to this. Well, notice that's negative 1.10, which is the same z-score except the opposite sign. Okay, so that was a z-score of negative 1.10. So you can look up 0.1350 for the area, but notice what side we're on is the positive z side. Okay, so that's because of the symmetry that works out that way. I could care less which way you do it as long as you get it right. Okay, and now using the inverse norm, okay, we have to look at putting the complement piece in there, 0.8650, which remember was all of this area to the left there. Okay, and then 0, 1. Okay, and it gives you 1.10 for the z-score. Okay, 54, part E, 54.62 area to its right. Well, again, 54.62% is 0.5462. Okay, that's something that students have a hard time with sometimes, is when you're given the percentage, remember that as a decimal between 0 and 1, that percentage we're given, 54.62, you move the decimal 2 places left to get 0.5462. So the complement of that is 0.4538. Okay, so do 1 minus 0.5462. Okay, so again, you can look up either of those values, but now we're on the left-hand side because 54% or 54.62% is bigger than 50. So that means that we're farther to the left of 0 than 0. Okay, we're 4.62% farther to the left of 0. Okay, so we get a z-score of negative 1.22. I'm sorry, negative 1.2, which again is what z-score we're closest to. Okay, so if you want to go and look at the table, you can. Okay, but moving along, we're going to find the z-scores of a different kind of question here, the middle 70%. Okay, well, the middle 70% of the data, okay, because we're looking at the middle and because of symmetry, what that's basically telling us, okay, let me cover up the actual answers here. Okay, what that's telling us is that 70%, or 0.7000, is in the middle, which tells us we have 30% left over to split between the two ends. So if you do that, you get 0.1500 on each end, okay, or to the left of this value, to the right of this value. Okay, so what we want to look up, if you look up a z-score of, an area of 0.1500, that gives you a z-score of negative 1.04, and because of the symmetry, we'll get positive 1.04 on the other side. To get the positive 1.04, if you looked up as area of 0.8500, which would have been 0.7 plus 0.15 is 0.8500, you would get 1.04. Okay, and there, if you do the inverse norm of the 0.15, you get negative 1.04. If you did inverse norm of 0.85, again, that was 0.7 plus 0.15, that would give you positive 1.04. You just have to recognize we're looking for two z-scores here. We're looking for the left side and the right side that has the middle 70% between them. Okay, so take a minute and try the middle 95% of the data. Okay, so do the same thing, and I'm just going to show you the answer here. So if you need to pause the video, go ahead. Okay, and I'm just going to show you the answer. Okay, and when you look at that, we're basically saying between negative 1.96 and 1.96 standard deviations from the mean, you have 95% of the data. Now, if you remember the empirical rule, it said 95% of the data was between negative 2 and positive 2. Well, again, this is that was rounding up to 2 and down to negative 2. But the closer answers, or more exact answers, are negative 1.96 to positive 1.96. Okay, something people miss on this one a lot is when you look at 0.95 area in the middle, you have 5% left over. Okay, so 5% is 0.05. Divide that by 2, and that gives you the 0.025. Okay, people say 0.25 a lot, but that'd be 25%. Okay, so 0.025 is half of 5%. Okay, so that's how you find z-scores for the middle, whatever percentage of the data. Okay, now where this is going to apply to us is now we're going to look at percentiles. Okay, and really what a percentile is area in disguise. So when you look at the z-score that goes with the following percentiles, 40% or the 40th percentile, that means 40% of the data is to the left of whatever P40 is. Okay, so On the diagram of a normal curve, it's a terrible normal curve. Remember, 0 for z is right in the center. Well, that will be 50% to the left of 0. Well, we want 40% to the left, so it'll be over here just a little bit and shaded to the left. So what we need to find is what z-score has 40% to its left. Okay, so that's just like the last questions, or the previous page. It's basically telling us the area is 0.4000. Okay, so what you do is look up the area, 0.4000. So you look for 0.4000 in the body of the table. Now I'm on the negative z-scores because I know that 0.4 is less than 0.5, so we're going to be somewhere in the negative z-scores. And then, let's see, as we go through this, 0.4000, well, I'm somewhere down in here. So 4000, it looks like 4013, 3974. Okay, it'd be between those two. Well, what is 4000 closest to? Well, that we're 13 away from this one, 26 away from this one. Now, another way to do that same thing is take 0.4000 and subtract it from each of these and see which number is greater, or what the absolute value is greater. So we're 13 below this one, we're 26 above this one. So we're closest to this, which is negative 0.2. Okay, so straight across, negative 0.2, and then up to 5. So negative 0.25. Okay, so the z-score is negative 0.25. Okay, and if you do inverse norm of 0.4000, comma 0, comma 1, okay, that'll give you negative 0.25 again. Okay, now what you might notice is that I try to make a habit of putting z-scores to the nearest hundredth, and I'm putting areas to 4 decimal places. So when you look at the area, I'm using 4 decimal places and 2 decimal places for the z-score. Because it's very easy to get confused that 0.4, well, maybe 0.40 is the z-score. Okay, you have to pay attention to the context of the question and what you're given in the question. It's very easy to get those backwards. Okay, and then if you try P90 and P99, so P90 means you have 90% to its left, and P99 you have 99% to its left. Okay, so again, take a minute and you can try those. I'm going to put the answers up here for the sake of time. Okay, so there's the answers for those. Okay, now moving along. Question number 3. Looking at the example of wait times from the first page. So we're using that same distribution of wait times from the previous videos. Find each of the following showing all work. Now that's a typo here. That should be the mean is 30 and the standard deviation is 6. So we want to find the wait time corresponding to the 90th percentile. So what that's basically asking us is what wait time has 90% of the other wait times to its left. Okay, so we just said above that P90 is a z-score of 1.28. Okay, that was from this one right here. Now notice that it did not matter if we were looking at wait times, if we're looking at heights of men, weights of women, ages of cars. It doesn't matter what we're looking at. When we have a normal distribution, P90 always corresponds to a z-score of 1.28. And again, that's the power of the normal distribution. Okay, so we know that P90 has to have a z-score of 1.28. Now, what this is basically asking us is that when we look at 90% of the area to the left, we know that the z-score is 1.28, that happens. What we want to find is what x value is that. Okay, remember, x is the actual wait time. So what wait time has a z-score of 1.28? What this all comes back to, remember in the last video, I said we go from x to z to probability. Well, now we're going from probability, which was 0.9000, to the z-score, which is 1.28. Now we have to use that to find x. So what we're doing is we're going in reverse. We're going from p to z to x. So we're going to use our z formula that always is true. Z equals x minus mu over sigma. Well, z, now we know that, is 1.28. X is the wait time, which we don't know. Mu is the mean, which we know is 30 minutes. Okay, 30 minutes. And then sigma is a standard deviation of 6. Okay, so we plug in the values that we know, and we're trying to find the wait time x. So solve that equation. To undo dividing by 6, you multiply both sides by 6, and that'll give you 7.68 equals x minus 30. Okay, so what we did there, we did times 6, so they cancel here, times 6 over here. Okay, we'll give you 7.68. And then add 30 to each side, you get 37.68. Okay, so a wait time of 37.68 minutes corresponds to the 90th percentile, which means 90% of the wait times are less than 37.68 minutes. Okay, that's how you interpret that. Okay, next one, find P10 and explain its meaning. So P10 will be the 10th percentile. Okay, so again, I'm going to suggest that you pause the video, and then in a few seconds I'll put the answer up. Okay, so on this one, 10, you have 10% to the left is a z-score of negative 1.28. Now that should make sense because 10% is the complement of the bottom 90%. So that z-score will be the same just on the other side at negative 1.28. So that's what happened down here. So we know the z-score is negative 1.28 equals x minus 30 over 6. So now when you multiply each side by 6, okay, so now when you do that, you get negative 7.68. Add 30 to each side, which is basically 30, take away 7.68, you get 22.32 minutes. Okay, so what does that mean? 10% of the wait times are less than 22.32 minutes. Okay, then the last question. Find the wait times of people in the middle 50%. So how long did people wait that were in the middle 50%? Okay, and again, I'm going to say pause the video if you need to. Okay, I'm going to show you the graph first. Okay, so those are the z-scores, negative 0.67 and positive 0.67. So basically, if you have 50% in the middle, you have 50% to split between the two ends. So there's 25% or 0.2500 area on each end. So then we have to find the wait times that correspond to this z-score of negative 0.67. and then find the wait times that correspond to positive 0.67 z-score. Okay, so there's the positive. Oh, I'm sorry, there's the negative. Okay, and then there's the positive. Okay, so you end up with the wait time being between 25.98 and 34.02 minutes. Okay, so that takes care of that video of basically finding a given area or z-score. Can you find the value of random variable x? Okay, so you need to go through and practice several of these out of the book and the homework online. And once you get the hang of these, it's not too bad. But again, it comes back to this idea up here. If you start with x, so what's the probability that a wait time is less than 35 minutes? You're starting with x, convert it to z, find probability. If it says find the value of the 90th percentile, like it did here, that means you're starting with a probability of 0.9000, convert that probability into a z-score, and then into x. Okay, and again, the calculator will help you save a lot of time rather than looking up in the table. Okay, so that's it.